Hi, welcome to Mrs. Patterson's Homework Help. We are on Chapter 8, Lesson 2. And we have prime and composite numbers that we're going to talk about. And I'll go over what those are again. You have to tell whether these are prime or composite, and oopsies, and whether or not these are prime, composite, or neither, and I'll talk about that in a minute. And then some other problems that we need to work through. Okay, all right. First of all, let me just get out the door with the fact that prime number has two factors, the number 1 and itself. That's the only factors they have. Two factors. I need to write that. 1 and itself. A composite number has 3 or more factors. Okay, so there is some numbers or digits, I should say, that are exempt. The number 0 is neither prime nor composite, and the number 1 is neither prime nor composite. So those guys are rule breakers. They're not prime or composite. 1, because it makes itself 1 and itself, it can't be 1. It doesn't work. They don't consider 1 a prime number. Okay, just believe that. And it's sometimes tricky to find prime numbers. I always like to let the kids know what the first 8 prime numbers are, so you can kind of memorize those and remember that, hey, these are not prime, or these are prime. The first prime number is 2. Then we have 3, 5, 7, 11, 13, 17, and 19. Those are the first 8 prime numbers. Remember, prime numbers go on forever, and people are constantly discovering more recent prime numbers. So these are the first 8, and it's good to memorize those to get yourself acquainted with them, and that way it's a little easier in your math process. Like, oh, I know, hey, 7's a prime number. Boom. It will help you. Okay, so now that we've decided what a prime number is, we also know that if we're making an array can only have one possible combination. Like if we're doing the number 7, we can only make an array 1, 2, 3, 4, 5, 6, and that's 7. So 1, 2, 3, 4, 5, 6, 7. This is the only way that I can make an array with the number 7, and that's because it is a prime number. Whereas composite numbers, say let's take the number 8, we can do the composite number 1, 2, 3, 4, 5, 6, 7, and that's 8, 1 by 8, or we could have 1, 2, 3, 4, 2 by 4. There's 2 different ways that we can do an array, so we know that that's a composite number. Okay? All right, now that I've covered that, they go through these explanations to you, okay? And even give an example of 13. 13's prime, 1 by 13, that's the only way you can make that array, okay? So another thing to look at too is that if you get rid of these numbers, don't look at those numbers in a multiplication chart. All of these numbers are composite here. Don't count the 1 by 1s because there's prime numbers in that. But otherwise, on your multiplication table, these are all composite numbers, okay? Because they're got there by another means other than 1, okay? So that's kind of a good way to look at it too. And when you're looking and to say, hey, is the number 16 prime or composite? If you can find it on your multiplication table in the middle, not on one of the 1 rows, then you know it's a composite number, because I could use 4 by 4 to get to 16. I can use 2 by 8 to get 16. There's more than one way to get to 16, so I am for certain it is a composite number. Now the next one is 37. Let's look. First of all, do I see 37 anywhere on my chart? I do not, okay? So I'm suspicious that it could be a prime number. But do I know for sure? Well, there's one way you can find out, unless you have a bigger multiplication chart, is, okay, so I've got the number 37. Can I divide it? Okay, first of all, can I divide it by 2? Well, no, it's not an even number, so it's not going to divide by 2. Well, what about 3? Okay, that's good. Oops. Can I fit 3 into 7 evenly? No. So that's not going to go in evenly. Well, if I couldn't put 2 into the number, I'm not going to be able to put 4 in the number. 5 won't go into it because it doesn't end in a 0 or a 5. 6, if I couldn't get 2 or 3 in, I'm not going to get 6 in. Well, what about 7? Well, this I can't fit any in here, so I know it goes in there 0 times, and then I'm going to get 37, and I'm going to repeat the process. I have 28. If I did by 4, 5 would be 35. No, it doesn't fit in evenly. And I have a remainder. So you can keep going on, and the reason it's kind of interesting is you notice which ones I was successful in looking at? 2, 3, 7. I'm using those prime numbers to see, the lower prime numbers, to see if I can determine if this is a bigger prime number. So I can keep going on. I can't do 8 if I couldn't do 2. I can't do 9 if I didn't do 3. I can't do 10. It's not an even with 0 at the end. 11. Well, the closest thing I could get would be 33 and then 44, so that doesn't work. What about the number 13? Can I get 13 into 37? Well, let's have 13 times 3, basically. That's 39. Okay, you're done. If you've looked at that many combinations and stuff, you know that this number is a prime number. This was composite. So this takes a little bit of work to figure out whether or not a number is prime or composite. It's actually easier to find out composite numbers than primes. But don't be fooled. Just because the number's odd doesn't mean that it's prime. You still got to investigate and look. For instance, 81 is an odd number, but you are going to find 81 on your multiplication tables right here. So that means it is composite numbers. Don't get odd numbers that all prime numbers are odd numbers and all odd numbers are prime numbers. That isn't true. And remember that 1 is neither prime nor composite. Okay? So on the back you have several more that you're going to determine whether it's prime or composite. Then you have 4 questions to answer. This one wants you to figure out which one's prime and which one's composite. And the same thing for test practice here. Okay? Alrighty, our bonus for today is, hey, the number 102, is it prime or composite?